Assalamu alaikum. Welcome to Turkish Engineering. In this problem, we don't know the reaction order, but we have a complete information about the reactor data. So we can use the time and conversion data in order to calculate two unknowns, which are the reaction order, which is n, and also the reaction rate constant, k. So let's start solving this problem. First of all, it's a batch reactor, so we can use the general equation of the batch reactor. So it is K times Ca to the power of n, right? Reaction order. Then we will separate the variables. So we will bring Ca here down. Ca to the power n is equal to Kt if you integrate K dt, but integrating it, or we can also show that step K dt, we are integrating from 0 to time, and here from Ca is not to Ca, and we can also show that it's going from 1 to Ca because the initial concentration is given. So you have minus because of this sign. Then you have dCa over Ca to the power n. Or you can represent this in the numerator as minus n dCa is equal to Kt. This is Kt when you integrate this part. So this part is remaining. So how to solve this integration? It is just power to the minus n. So we will increase the power by plus 1. So we can also show it like 1 minus n. Instead of minus n plus 1, we can show it as 1 minus n. We have 1 minus here. Then to the this one will be also down, 1 minus n. The boundaries are 1 to Ca. You can distribute this minus sign to below, so you get Ca to the 1 minus n over n minus 1, and it is from 1 to Ca. Okay, so we have Ca, you can put Ca, then you can put 1, so you have Ca 1 minus n, minus you put 1, so you have 1 to the power 1 minus n, so you get only 1. This is just 1. And you have in the common denominator, you have n minus 1. So if you simplify again, so this is the answer of the performance equation. This is called performance equation of a reactor, K times the residence time. You can also show it by residence time as a tau sign or T. Okay, so far so good. We need to just implement our we can say the conditions for this equation in order to find the unknowns. Okay, so we can start by this. Okay, the good thing that we can do here is converting concentration to x, because we know x. So Ca, instead of Ca, we can put 1 minus x multiplied by Ca naught, and we know that Ca naught is equal to 1. So it is just 1 minus x. Okay, so instead of Ca, you can put 1 minus x. So rearranging the equation, we have 1 minus n minus 1 here, n minus 1 is equal to Kt. So let's use first run. So instead of t, I will use 8 minutes, and x is 0.8. Okay, so let's put it. So you will get 1 minus 0.80 to the power 1 minus n minus 1 over n minus 1 is equal to k times 8. So it is 8 times k. Okay, so you have something here. Good, very good. Here we have two unknowns. Still, we can keep it and go to second equation. So now, let's say now use second run when time equals to 18 minutes, and conversion is 90%. So you will have 1 minus 0.90 to the power 1 minus n over n minus 1. You have here also minus 1 is equal to 18 times k. Two equations. What we can do is just division. Just you can divide, okay? divide. So 8k over 18k, this divided by this, they will equal to each other. So they will cancel each other, n minus 1. So you will get 0.2 to the power 1 minus n minus 1 over 0.1 to the power 1 minus n minus 1 is equal to 8k over 18k. So k also will cancel each other. So you will have something like this. Then you can solve for n. Solve for n. You can solve for n by using the calculator if you have a shift solve, or also you can use by using trigonometry. I'm sorry, not trigonometry. It's logarithmic functions. Logarithmic functions. Okay. So how could we do it? Okay, 18. You can bring it to other side. So 18. 0.20, 1 minus 1 minus 1 is equal to 8 times 0.1 times power 1 minus n. Okay, it's actually distributed here, so it is also 18. So you distribute this to this numerator and this to other numerator. So you have 8, also you have minus 8, okay? So we can rearrange this by sending the constant to other side. So you have 18 times 0.20 1 minus n minus 8 0.1 1 minus n is equal to, if you send this guy to other side, you will have 10. Then you can get logarithm of both sides, maybe logarithm of both sides. Is it possible, or should we get a common factor? Actually, I'm not sure to like move algebraically by this. So if I get ln of both sides, here you will have ln 10. Okay. So this is also should be arranged as a common factor, and I'm not sure how to move by this. So I will use the calculator. Okay. So let's use the calculator. So you have 18. We can use this one also. 18, or we can use the simplest one here. Let's use it. So it will be 0.20 to the power 1 minus x minus 1. Then you have 0.10 power 1 minus x minus 1 is equal to 8 over 18. Shift solve, and I have, it's like, let's put 1 as an estimation. So we get 2. Okay, that's good. Solve for n, we get n is equal to 2. Okay, so reaction is a second order reaction. And when we solve for n, we can go to any one of them, any equation that we derived, and we solve for the other unknown, which is k. Okay, since we know the n, we can now solve for k. So k is equal to 1 minus 0.80, 1 minus 2 over 2 minus 1. Here you have also minus 1, 1 over 8 multiplied by 1 over 8. So if you do this operation, 0.2 to power of minus 1. Here you have minus 1 divided by 1. Actually multiplied by 1 over 8, so you will have 8 here. So you will get 1 over 2. 1 over 2. So that means that the reaction equation can be written as k Ca power n, and it is 0.5 Ca to the power 2. This is the reaction equation that can be written. I'm sorry for the algebraic part that I couldn't solve this one. If ln was like, if we were able to like put them as a common factor, we can bring it to down. So we can transfer this one to here, and we can solve for 1 minus n. So this is how logarithmic functions help us. But I'm stuck in this algebraic part, and mostly this kind of problems is easy to solve by using a calculator. So you can move by a calculator and find n. Then after finding n, you can easily find k by just substitute n into any one of these two equations that you derived, and you are done with the problem. I hope you enjoyed the problem, and see you at the next video. Thank you for watching.